Good evening.
Good evening, sir.
Sir, able to hear?
Yes, sir.
Okay. Rearrangement reactions. One more rearrangement reaction. This one. The previous class, different memory reactions are explained. Xylene rearrangement is our previous class. The orthoxylene or paraxylene with HF and Lewis acid rearranges to the metaxylene. Why metaxylene, sir? Metaxylene is thermodynamically stable. Yes or no? Next, Hoffman rearrangement, sir. Now I will explain Hoffman rearrangement. Hoffman-Mortis rearrangement. Sorry. Hoffman-Mortis rearrangement. Basic reaction, N-alkyl aniline with hydrogen halide with HX rearranges to the at high temperature, nearly 150 degrees centigrade. It is rearranges to the alkyl anilines, orthoalkyl aniline and para-alkyl aniline. Plus para-alkyl aniline. How this rearrangement takes place here? What is the mechanism for this rearrangement here? Hoffman-Mortis rearrangement it is. Mechanism for this rearrangement. This N-alkyl aniline reacts with H plus and Br minus here. H plus nitrogen is a lone pair to the H plus here. What is the charge present on nitrogen now? Positive charge. The nitrogen has positive charge. Next, Br minus is eliminated here. The nitrogen has positive charge. This bond breakage takes place. Br minus is added to the R plus here. Now it is connected to the aniline here. It is connected to the aniline. Declare form like the nitrogen increases electron density to ortho and para position, sir. When it donates electrons to the ring, ortho carbon is getting negative charge. Ortho position hydrogen is there, ortho position negative charge. Next, alkyl bromide is there here. Alkyl Br, RBr is there. When alkyl bromide is present, elimination of Br minus, negative charge transfer towards R group. Negative charge transfer towards R group. Like this, alkyl group is bonded to the ortho carbon. R group is bonded to the ortho position. Alkyl. The next step, elimination of proton. Proton elimination takes place. Nitrogen is getting pumped. Like this, ortho alkyl. Para means same like this. Para position negative charge. Amino group increase, OP directing group. Therefore, it increases electron density of para position. Position negative charge is present. Now the alkyl group is attached to the position. Same isomer. Like this, ortho and para positions correct. For example, just 2-3 examples are there in this one. N-methyl aniline. On this arrangement gives what the product? With HBr. What the product here? Orthomethyl aniline and paramethyl. Orthomethyl aniline and paramethyl.
ఇంకో మాట్లాడుతున్నారు ఇంకో మీ సార్ ఏదో కదుపుతున్నారు హిందీగాని ఒక నిమిషం అలా అసలు లైన్లో ఉండు అది స్క్రీన్ పైకి కదిపి ఏదో రాస్తున్నారు అయింది వస్తుంది కూడానే పెట్టాను అలాగే వాల్యూమ్ బటన్ నాకు నొక్కడం రాదు కట్ చేసేస్తాను అలాగే రెడ్ అది నొక్కేస్తాను
What is the product, sir?
మాట్లాడుతున్నారు మీ సార్ మాట్లాడుతున్నారు చెప్పు
What is the group attached to the aniline ring? Methyl group or ethyl group? Sir, able to hear?
Yes, sir.
Sir, వినపడుతుందా?
Yes, sir. Yes, sir.
మరి చెప్పండి సార్, ఆన్సర్ చెప్పండి. విచ్ గ్రూప్ ఇస్ అటాచ్డ్ టు ద రింగ్? Which group is methyl or ethyl? Sir, in the mechanism, when the nitrogen alkyl bond breakage takes place, R group is getting what the charge? Positive.
Positive charge.
R group is getting positive charge. Which R group is stable with positive charge, ethyl or methyl? Ethyl. Therefore, what it forms now?
R and methyl.
NH, methyl, here, ethyl. Ortho position ethyl and para position ethyl group are ready. This is Hoffman-Martis rearrangement. Just two examples written here. Propyl group is present.
Propyl.
Hydrogen and propyl is there. HCl or HBr, whatever it may be. For example, HCl at high temperature. What is your answer?
Propyl. Orthopropyl and
Sir, in this case here, first we are getting the N-propyl carbocation. Yes or no? N-propyl carbocation. Then it is rearranges to the
isopropyl.
Isopropyl carbocation. Isopropyl carbocation is the bulky electrophile. Now this bulky electrophile goes to the which position?
Para position.
Para position is correct. Para one is correct. Next example. On nitrogen, hydrogen and isobutyl is there. Hydrogen and isobutyl is present. Then what is the port?
Tertiary.
Hydrogen and isobutyl. So now the same like that. Which first we are getting which cation? Isobutyl carbocation. Isobutyl carbocation is primary carbocation. Then it is rearranges to the tertiary carbocation. Tertiary carbocation. This is a bulky electrophile. It goes to the which position now?
Para
Position. Tertiary butyl. Para tertiary butyl anything. Like this rearrangement also takes place. Okay, this is called Hoffman-Martis rearrangement reaction. Hoffman-Martis. Next under rearrangement reaction. Wagner-Meerwein rearrangement reaction. Antismen. What is Wagner-Meerwein rearrangement reaction? The rearrangement of less stable carbocation to more stable carbocation. Less stable carbocation to more stable carbocation. Less stable carbocation to more stable carbocation. Is called Wagner-Meerwein rearrangement. Carbocation is the name itself, the definition itself indicates carbocation is the intermediate in these reactions. Some examples. N-propyl chloride with AlCl3. What is the product? Isopropyl chloride. Then Now the rearrangement of 1-chloropropane to 2-chloropropane. 1-chloropropane to 2-chloropropane is called Wagner. How the rearrangement takes place means N-propyl chloride reacts with AlCl3. Aluminium has vacant orbital. Now primary carbocation we are getting plus AlCl4 minus. So this is the primary carbocation. With hydrogen transfer, with 1,2 proton transfer hydrogen transfer takes place, H minus transfer takes place. Primary one is rearranges to the secondary carbocation. Secondary carbocation. When it reacts with AlCl4 minus, Cl minus here is the secondary isopropyl carbocation. Like this we are getting 1-chloropropane is rearranges to the 2-chloropropane. 1-chloropropane to 2-chloropropane is an example for Wagner-Merriman rearrangement. Next examples. Isobutyl bromide with AlBr3. AlBr3. What is the product here?
Tertiary.
First isobutyl carbocation we are getting. Then hydrogen. Tertiary butyl carbocation. AlBr4 minus. Tertiary butyl bromide. Like chloride bromide. Next example. Neopentyl chloride with AlCl. What is your answer? Same. Cl minus reacts with this one. First it forms neopentyl carbocation is primary. Ethyl group migration. Tertiary pentyl carbocation. AlCl4 minus. Tertiary pentyl chloride. Tertiary pentyl chloride. Tertiary pentyl chloride. Neopentyl chloride is rearranged to the tertiary pentyl chloride. Okay, next one. Like this bicyclic compound is given. First, what it forms here? Secondary carbocation. Secondary is rearranges to the tertiary. Hydrogen transfer. Next, this is the bicyclic compound. The ring size 4. The ring size is increases. Ring breakage takes place. The ring expansion takes place. This ring expansion, we are getting the product like this. Here it is getting positive charge. Next, AlCl4 minus. Fluoride is attached. When the bicyclic compounds are present, like this rearrangement takes place. Okay. Adamantization reactions also example for Wagner-Merriman rearrangement. This is about Wagner-Merriman rearrangement reactions. Examples. The all rearrangement reactions are over. Most all rearrangement reactions, important rearrangement reactions are completed. In this rearrangement reactions are first one pinacol-pinacolone rearrangement. Diols to carbonyl compounds. Next, Beckmann rearrangement is also very important. Oximes, ketoximes to enolcalamides. Next, Favorsky rearrangement, benzyl benzylic acid rearrangement, hydrozobenzene and benzene rearrangement, hydrozobenzene and benzidine rearrangement, Fries rearrangement, Claisen rearrangement, all these Arcton rearrangement and Baeyer-Villiger oxidation or Baeyer-Villiger rearrangement, all these are very important in entrance spectroscopy. Rearrangement reactions are over. Rearrangement reactions are completed here. You know, the coming Sunday for the exam syllabus, you have to write rearrangement and elimination reactions both. Okay, na?
Okay, sir.
Coming Sunday, elimination reactions and rearrangement. Organic syllabus. Elimination and rearrangement. I will post the notes today evening after class. Rearrangement reactions అది పీడిఎఫ్ నోట్స్ ఉంది, అది పంపించేస్తా. ఇవి మీకు ఎక్స్ప్లెయిన్ చేసిన ఎగ్జాంపుల్సే ఉంటాయి కాబట్టి స్క్రీన్ షాట్స్ అవసరం లేదు, పీడిఎఫ్ నోట్స్ పంపించేస్తా స్టూడెంట్. నెక్స్ట్ హైడ్రోకార్బన్స్ ఐ విల్ కంటిన్యూ సార్ నౌ. హైడ్రోకార్బన్స్ అంటే మనకు మార్నింగ్ క్లాస్లో ఏమైంది, ఆల్ చైన్స్ కదా, ఆల్ కైండ్స్లో కెమికల్ ప్రాపర్టీస్ వేర్ ఎక్స్ప్లెయిన్. In the hydrocarbons morning reaction మనకి ఏం చెప్పాం ఇక్కడ, hydroboration, alkynes and hydroboration oxidation with the product you are getting. Acetylene hydroboration, what it forms? Morning general examples. Acetylene hydroboration, acetaldehyde. Yes or no? For acetylene, if you take the acetylene hydroboration of B2H6 H2O2 peroxide and base and acid is present, addition of the BH3 అంటే మనకి ఇక్కడ డైరెక్ట్ రాస్తుంది H and OH, vinyl alcohol, on tautomerization it forms acetaldehyde, but it gives alkene. With acid it forms alkene. One alkynes also same, one alkynes on hydroboration with oxidation aldehydes, one alkynes with aldehyde. One alkynes hydroboration of B2H6 and peroxide and base, it forms aldehyde or CH2CH. Because BH2 is present on terminal carbon, BH2 group it changes the OH, OH is present on the terminal carbon in all form, tautomerization aldehyde. Next, second one, internal alkynes hydroboration with oxidation. Sorry, important reaction, sorry, hydroboration with oxidation.
Ketone.
What it forms here? Ketone.
Ketones.
It forms ketones. Hydroboration with oxidation is ketone here. If the acid is present, cis alkene we are getting. Acid is present, cis alkenes we are getting here. Here just one or two examples only. So these are the general examples you have to remember. Propine. But it forms propanaldehyde. Propine gives propanaldehyde. Now the 2-butane gives which one? Same reason, 2-butanol. 2-butane gives 2-butanol. One alkane gives aldehyde, two alkanes gives ketones. Next, phenylacetylene. phenylester on hydroboration with oxidation. Phenyl propane. Hydroboration with oxidation. Next. Cyclopentyl acetylene. Hydroboration with oxidation. Next. Cyclooctane. Hydroboration with oxidation. Next. 2-butane with hydroboration with acids. Acetic acid. The first one, phenylacetylene is which compound?
Phenylacetylene.
Here it forms the phenylacetylene because one alkyne's hydroboration with oxidation is aldehyde. Phenylacetylene or 2-phenyl ethanol. The phenylacetylene. Next one. Which position ketone, sir? Which position ketone?
Second position. Second position.
Sir, here the addition of BH3, sir. BH less steric position. Phenyl is therefore what is the compound we are getting? Addition of BH3, the compound is like this: H double bond BH2 and CH3. BH2 position we are getting the OH. Therefore, tautomerization we are getting CH2 C double bond O CH. This is correct answer. Hydroboration reaction is concerted mechanism, sir. BH2 is added to the less steric carbon. Okay, that's why the here also cyclopentyl acetylene use
Aldehyde.
cyclopentyl acetylene or cyclopentyl ethanol. Next, cyclooctane on hydroboration with peroxide use
Cyclooctanone.
Enol form tautomerization cyclooctane. Next compound, sir. Sir, ఇక్కడ acid ఇచ్చాం, not hydroboration with not oxidation reaction. If the acid is present, BH2 group is replaced by the
Hydration. H.
BH2 group is replaced by the H here. Okay, now the which addition, cis addition or trans addition here? Hydroboration which addition? Cis addition. Therefore, cis-2-butene we are getting. CS3, the hydrogen, here the hydrogen. So this is called cis-2-butene. Cis-2-butene we are getting this one. Okay, clear? Like this question they will ask in the entrance. Hydroboration followed by oxidation followed by this one. Okay, next one. Okay, next another important reaction of alkynes, ozonolysis reaction. Alkenes ozonolysis is very important when compared to the alkyne ozonolysis. In alkene, different types of process are getting. In alkyne ozonolysis reaction, ozonolysis, addition of ozone. So when alkynes reacts with ozone, what it forms here? Alkynes on ozonolysis reaction, what it forms now? Ozonate followed by hydrolysis is common. What it forms? 2 moles or COOH. Acids. Alkenes on ozonolysis, carbonyl compounds. But alkynes on ozonolysis gives carboxylic acid. Alkynes on ozonolysis gives carboxylic acid. How this reaction takes place? What is the mechanism? When it reacts with the ozone already in alkenes already explained the mechanism similar to that one. One oxygen has negative, another oxygen has positive. Okay, now the now the triple bond electron transfer towards this one, like this way. Like this cyclization takes place. With this cyclization, we are writing the RC double bond C oxygen oxygen like this. Three oxygens are continuous. This is called as which one? Malozonide. Yes or no? Okay, this is unstable. Lone pair repulsions are present here. Because of lone pair repulsion, stability decreases. Now the peroxy bond breakage takes place. Any one of these peroxy bond breakage takes place. When the peroxy bond breakage takes place, like this one, like this peroxy bond breakage takes place, this oxygen is getting negative charge. Here the oxygen is getting negative charge. It is changes to the ketone here. Left side carbon is changes to the ketone. R C double bond O and C here
లేదా అసలు కొట్టినాను
negative. Oxygen has what is the charge here?
Oxygen negative. Carbon.
Oxygen has negative charge here. This has negative charge. And the carbon has electron transfer. It has positive charge. Okay, next step. Carbonyl oxygen joins the lone pair here. The direct oxygen positive, then electron transfer. Here it is getting positive, negative charge transfer. Like this cyclization takes place again. It forms primary ozonide, alkyne primary ozonide. R C O O C and O C C bond is present. Sir, what is the difference between alkene ozonide and alkyne ozonide?
CC bond.
So C is in alkyne. In is no cis bond. So this is the difference between alkene ozonol-cis and alkyne ozonol-cis. In alkene primary ozonide, no CC bond. Here the CC bond is present. Here the in the CC bond, one is 3-membered ring, another one 4-membered ring. Therefore, this is also unstable. This ozonide is also unstable. Now the here the breakage of the ring. How the ring breakage takes place? When this bond breakage takes place, CC bond, like this we are getting. What is the compound we are getting? Sir, R
C double bond.
C double O next to O C double bond O R. Okay, this is called it is
Anhydride.
acid anhydride form. Now the acid anhydride next to hydrolysis. Acid anhydride on hydrolysis gives 2 moles
2
acid.
moles of
Okay, this is the mechanism for alkyne ozonolysis reactions. Okay, alkyne ozonolysis. Alkynes on ozonolysis gives final products are carboxylic acids. Carboxylic acids we are getting. Ozonolysis reaction, generally we are getting the carboxylic acids. So first we are getting the glyaxal, acetylene. If you take the acetylene, glyaxal on oxidation gives acid also. Suppose propine. If you take the propine on ozonolysis, ozone and water, what it forms now? Acetic acid and
formic acid. Formic acid.
acetic acid and formic acid. 2-butane on ozonolysis. Next 2-pentane on ozonolysis. Next, cyclohexane on ozonolysis. Cyclohexane on ozonolysis. Next, cyclooctane on ozonolysis. Second, sir, for the products here, 2 butane is 2 moles acetic acid. 2 moles acetic acid. 2 pentane is
acetic acid plus propanolic acid.
acetic acid plus propanoic acid. Acetic acid plus propanoic acid. Cyclohexane is
Dioic acid. Dioic acid.
dioic acid, adipic acid. Cyclooctane is octane, 1,8.
1
Octane dioic acid. Octane dioic acid. Very good. Simple conversion, simple one. Compound X on ozonolysis gives on coal-based electrolysis gives coal-based electrolysis gives NX. What is X and Y? X on ozonolysis gives Y, sir. Y on coal-based electrolysis gives NX. What is X and what is Y?
5-butanoic acid, sir.
Very good. Okay, hexane means 6 carbons. Symmetrical break is 3 carbons with acid. Butanoic acid. Very good. Y is butanoic. What is X?
Octane. 4 octane.
This one, 4 octanes.
4 octane.
4 octane only on ozonolysis gives only butanoic acid. 4 octane on ozonolysis gives butanoic acid. Butanoic acid. 4 octane. 4 octane is correct. Okay. The next one. It is about ozonolysis and related examples of alkyne. Next, oxidation with selenium dioxide or cold KMnO4, cold alkyne KMnO4. Oxidation reactions. Selenium dioxide or cold alkaline KMnO4. With both the reagents, products are same, sir. With both the reagents, products are same. Cold alkaline KMnO4 is called Peirce reagent. For example, if you take the acetylene with any one of these reagents, selenium dioxide or cold alkaline KMnO4, oxidation reaction. But it forms no Glad salt. This is called glad salt. One alkynes are present with these reagents. One alkynes are present. Alkyl glad salt. This reagent forms alkyl glad salt. Next, internal alkynes are present. Dialkyl glad salt. Internal alkynes are present, dialkyl liaison. Okay. Just one or two examples. Propine. Propine on this reaction is methyl liaison. 2-butane gives dimethyl liaison. Dimethyl liaison. Dimethyl liaison. Next one, oxidation with hot cheminophores. Same like alkenes. Oxidation with hot cheminophore. Oxidation with hot cheminophore. So similar to the alkenes here. Acetylene with hot cheminophore. Oxidation. Same here, the hydrogen is replaced by the OH and 3 bonds are replaced by the triple bond replaced by the OH. Elimination of water. Elimination of water. CO2. 2 mole CO2 is released. Same similar to the alkenes. Alkenes already explained this. Same concept you can apply for. 1 alkynes oxidation with hot cheminophore is acid plus CO2. Internal alkynes gives 2 moles acid.
2 moles.
Symmetrical one is present, 2 moles acid. Here just one example. X with hot cheminophore of 2 A3-hexene, A3-hexene, B3-hexene, C 4-octane, 2-pentane. 2-pentane. What is your answer?
AB.
Both alkenes and alkynes and oxidation with hot cheminophore gives acids. Therefore, A and B correct. 3-hexene is correct. 3-hexene is also correct. Both alkenes and alkynes, oxidation with hot cheminophore gives acids. Both are correct here. Next, some other reactions of alkynes. Addition of arsenic trichloride. When alkynes reacts with addition of ASCl3. What it forms here? When acetylene reacts with ASCl3, addition triple bond becomes double bond Cl and ASCl. This is called Lewis-Site. Next, addition of acetic acid to the acetylene. Addition of acetic acid to the alkynes. For example, acetylene plus acetic acid, what it forms? Addition of proton to the triple bond carbon, it forms vinyl acetate. It forms vinyl acetate. Vinyl acetate. Next, addition of carbene. Addition of methylene carbene. Addition of CH2. Addition of methylene carbene. Alkynes and addition of carbene here. For example, acetylene plus methylene carbene, we are getting A. A again with methylene carbene, we are getting B. What is A and B? What is compound A? Carbenes already explained this reaction.
Fused by say.
Huh?
Cyclopropane.
Addition of carbene to the triple bond becomes double bond.
Double bond.
Cyclopropene. Very good. Cyclopropene. Mal again carbene add cheste?
Cyclobutane.
Huh?
Cyclobutane.
cyclobutane కాదు, bicyclic compound. Bicyclo 110 butane. Okay, fused bicyclic compound we are getting. Bicyclic వస్తుంది సార్, నాట్ మోనోసైక్లిక్. Bicyclic. Okay, this is cyclobutane, cyclopropene. Next bicyclic compound, bicyclo 110 butane. Like this, addition of carbene to the alkane. Okay, next one, isomerization reactions of alkanes. Next one, isomerization of alkanes. Isomerization లో two types of reactions ఉన్నాయి. One is first one, 1-butane with alcoholic NaOH or KOH. NaOH or alcoholic KOH. 1-butane is rearranged to the isomerized to the 2-butane. Conversion of one isomer to another isomer is called isomerization. How this reaction takes place? Mechanism for 1-butane to 2-butanes. Alcoholic KOH means what is the base in the alcoholic KOH or NaOH? Mechanism. For this one, mechanism. This is also important reaction. Isomerization reaction is also important. Local example ఎప్పుడు వస్తుంది సార్? మెకానిజం, how the 1-butane is changed to the isomerized to the 2-butane. When it reacts with the base,
నింపుకుంటావే
alpha protons. This is alpha hydrogens also acidic one. H plus negative charge like this. Functional group is triple bond, therefore it is called alpha. Like this, negative charge transfer towards here and electron transfer towards terminal carbon. Okay, now the terminal carbon has what is the charge here? Negative charge. Here the terminal carbon has negative charge. CH3 CH double bond C. Next again double bond CH minus charge. CH minus. Now the proton reacts with the alkoxide ion, then it forms alcohol. Now the alcohol donates the proton to the CH minus. Then it becomes what, sir? CH2. Proton is added to CH3 CH CH double bond C double bond CH2 on CH2. Then when it reacts with alkoxide ion, when the H plus reacts with alkoxide ion, again H plus reacts with alkoxide ion, again carbon ion. Next again same mechanism you can repeat here. CH3 C minus double bond C double bond CH2. Next negative charge transfer. Electron transfer towards primary carbon. Primary carbon ion is stable. CH3 C triple bond C CH2 minus. Next again alcohol. Now it's the proton. Then we are getting the 2-butane. Like this, 1-butane is rearranged to the isomerized to the 2-butane. Conversion of one isomer to another isomer is called isomerization. Okay, this is 1 alkynes to 2 alkynes conversion mechanisms. Okay, this mechanism is important. Like this, 1-butane is rearranged to the 2-butane. Next, second more isomerization reaction, sir. Another one, reverse anamata. Reverse ante enti? 2-butane to it is 1-butane. Second isomerization reaction, butane to 1 butane. The reagent is different, sir. Sodamide, NaNH2 or KNH2 and liquid ammonia, like with reduction reagent. What it forms now? 2 butane is rearranged to the 1 butane. 2 butane to 1 butane. Right. Two butane. How the rearrangement takes, how the isomerization takes place? 2 butane to 1 butane mechanism. The mechanism CS3 C triple bond C CS3. Okay, the methyl carbon is also alpha, triple bond bonded carbon functional group. This is a functional group alpha. This when the methyl proton reacts with the base here, NH2 minus, sir. The base is different here. The base is NH2 minus. KNH2 NH2 lo K plus and NH2 minus, or Na plus and NH2 minus, sodamide. And the H plus reacts with the base here. The methyl carbon has what the charge now?
Negative charge.
Negative charge. H plus reacts with the base. Therefore, it is getting negative charge here. Of 3 C minus double bond C H C C double bond CH. Okay, next. Here, which one you have to add? MHL, liquid ammonia. H plus from the liquid ammonia, H plus attached to this one, creating CS3 CH double bond C double bond CH2. Again same mechanism. Again NH2 minus base. Again this proton reacts with the base here. Thermal carbon is getting again negative charge here. CS3 C double bond CH. What is the charge here? Negative charge. Negative charge is present on this. Negative charge is present like this delocalization. With this delocalization, CS3 CH C triple bond CH, and it is getting what the charge? Negative charge. It is getting negative charge. When it is reacts with the liquid ammonia, H plus is attached on here. Like this, 2 butane is isomerizes to the 1 butane. Okay, this is the mechanism. 2 butane to 1 butane mechanism is like this. Okay, this is about isomerization of alkynes. Okay, 1 alkynes to 2 alkynes and 2 alkynes to 1. ఇక్కడ మెయిన్ రియేజెంట్ డిఫరెన్స్ సార్. 1 alkynes to 2 alkynes అయితే ఆల్కాలిక్ NaOH or ఆల్కాలిక్ KOH. But 2 alkynes to 1 alkyne sodamide or potassiumide with ammonia, liquid ammonia we are using. Both the reactions are very important, sir. Isomerization of alkynes. 1 alkynes to 2 alkynes and 2 alkynes to 1 alkynes mechanism is like this. So both the mechanisms you have to remember. Hello? Next one. Acidic hydrogen properties of one alkyne, sir. Acidic hydrogen properties of one alkynes here. Acidic hydrogen properties of one alkynes. Acidic hydrogen properties of one alkynes here. What are the acidic hydrogen properties of one alkynes? Sir, in the hydrocarbons, which hydrocarbon is more acidic here? One is, for example, ethane, ethylene, acetylene, and benzene. Which is more acidic, sir, here? A, B, C, D. Which is more acidic?
C.
C is more acidic. Why C is more acidic? Percentage of S, sp hybridization. When the S percentage increases, acidic nature increases. So the C is more acidic. C is more acidic. Next, one more example. So butane, butene, one butane or two butane, one butane, two butane. Which is more acidic? A, B, C, D. Which is more acidic here also? C is more acidic because in one alkynes, acidic hydrogen is present. C triple bond CH. Triple bond carbon hydrogen is more acidic here. Here also triple bond is there, but no acidic hydrogen here. Carbon bonded methyl is there, no hydrogen here. On triple bond carbons, no hydrogen in 2-butane. Therefore, one alkynes and two alkynes are present. Which are more acidic, sir?
One alkynes.
One alkynes are always more acidic when compared to the two alkynes. One alkynes acidic hydrogen is present, but in two alkynes no acidic hydrogen. So, same like that. One more example. One pentane, two pentane. Which is more acidic? Second, one pentane.
One pentane.
Acidic hydrogen. Next, phenylacetylene, diphenylacetylene. Which is more acidic? This is phenylacetylene. This is diphenylacetylene. Which is more acidic?
Phenylacetylene, sir.
Because acidic hydrogen is present in phenylacetylene. Acidic hydrogen is present in phenylacetylene. Acetylene and propane. Which is more acidic? Acetylene and propane is present. Which is more acidic?
Acetylene.
Acetylene more acidic. Because two acidic hydrogens. Two acidic hydrogens. Alcohol and acetylene. Which is more acidic? Alcohol. Because oxygen is more electronegative atom. More electronegative atom hydrogen is present, more acidic here. Compared to the triple bond carbon, oxygen is more electronegative. That's why the alcohols are more acidic. Okay? And compared to the ester. Next, some other reactions of some other acidic hydrogen properties of one alkane. C triple bond CH with sodium metal. Next one, sodium hydride. Next, sodium hydroxide. Next, Grignard's reaction. These are the acidic hydrogen properties of one alkynes. Okay, now the metal, acidic hydrogen is replaced by the metal here. It forms RC triple bond CN plus half H2. Next here also same plus H2. But NaOH plus 1 alkynes, no reaction, sir, because 1 alkynes are weak acids, therefore no reaction. The reason weak acids, 1 alkynes. Grignard's reagent reaction takes place. When the Grignard's reagent is present, what is the product we are getting? Acidic hydrogen is attached to the Grignard's reagent. R prime H, not RH. R prime H, MgX and C triple bond. C carbon is triple bond carbon is attached to the magnesium. Collect this with Grignard's reagent. Next, acetylene. When acetylene reacts with acetylene, HC triple bond CH. When acetylene reacts with 2 moles AgNO3, 2 moles AgNO3 plus ammonium hydroxide. 2 moles ammonium hydroxide. It forms what it forms? Silver esterlides here. Silver esterlide plus 2 moles ammonium nitrate, NH4NO3 and H2O, 2 moles water. These are the byproducts. Silver esterlide, like this silver esterlide. White PP, white precipitate we are getting. So these are the silver esterlides. When acetylene reacts with one more reaction, when acetylene reacts with cuprous chloride, U2 with ammonium hydroxide, it forms the copper slide. I put 2 moles ammonium chloride plus H2. H2. See, this is the copper slide. Red PP, copper. So these two reactions also very important. Sir, first reaction, what is the reagent we are using? Sir, what is that reagent? Anyone of you?
Chemical silver nitrate.
Huh?
College.
It is called Tollens reagent. Tollens reagent. It is Tollens reagent. Next, ammonium cuprous chloride is called Fehling's reagent. Fehling's reagent. The first one is Tollens reagent, second one is Fehling's reagent. Okay, now the like these questions will ask in the entrance. Which of the following hydrocarbon reacts with Tollens reagent? Which of the following hydrocarbon reacts with Tollens reagent? Okay, acetylene, and all 1 alkynes. All 1 alkynes reacts with Tollens and Fehling's reagent. Acetylene and 1 alkynes. All 1 alkynes reacts with Tollens and Fehling's reagent. Which hydrocarbon reacts with Tollens reagent? A ethane, B ethylene, C acetylene, D benzene. C. What is your answer? Only acetylene.
చేసి మళ్ళీ పెట్టింది కదా
Only acetylene reacts with Tollens and Fehling's reagent.
క్లాస్ ఇంకా కంటిన్యూ
Same question. Which of the following compound reacts with Tollens reagent or Fehling's Tollens reagent?
అవలేదు
A
ఇంకా
propane,
అవలేదు అదే అంటున్నాను
B propane, C. Propine. D. Acetaldehyd.
అలాగైతే
What is your answer?
అందుకే
C, sir.
Which compound reacts with Tollens reagents?
C.
C and D. Acetaldehyd
C
brother.
and
Aldehydes also. Aldehydes and ketones are separated by Tollens reagent. Aldehydes react with Tollens reagent, but simple ketones not reacts with Tollens reagent. Therefore, aldehyde ketone separation also we are using Tollens reagent. Yes or no? Therefore, C and D correct answer. Which of the following compound reacts with Tollens reagent? A. Butane. B. Butene. 1 butene. C. 1 butane. D. 2 butane. What is your answer?
C, sir. C, sir.
Here only C. Then now the for separation of one alkynes and two alkynes also we are using the Tollens and Valence reagent. One alkynes and two alkynes separation. Therefore, what is your answer here? Only C. Only C. Next one. Phenylethylamine. Same question. B. Diphenylacetylene. C. Glucose. D. Fructose. ఐడియా ఉందా మీకు గ్లూకోజ్ ఫ్రక్టోజ్ కూడా మనకు వచ్చింది కదా న్యూక్లియోఫిలిక్. విచ్ వన్ రియాక్ట్స్ విత్ ద టోలెన్స్ రియేజెంట్స్?
A, C, sir. C, D. A, C, sir. A, C.
ఏ ఇస్
అది ఆఫ్ చేసేయాల
కరెక్ట్ ఆన్సర్. ఎసిడిక్ హైడ్రోజన్ ఇస్ there, but fructose also reacts. Simple ketones not reacts, but alpha hydroxy ketones. Alpha hydroxy ketones reacts with Tollens and Valence reagent because with indiol rearrangement alpha hydroxy ketone it changes the aldehyde. మనం అక్కడ ఆల్రెడీ మెకానిజం రాసాం. ఆల్డో షుగర్ కీటో షుగర్ కన్వర్షన్స్ లో మనం న్యూక్లియోఫిలిక్ అడిషన్ కూడా వచ్చింది. లైక్ దిస్ ఫ్రక్టోజ్ ఆల్సో రియాక్ట్స్ విత్ దిస్ వన్ Tollens reaction. Simple ketones not react, but alpha hydroxy ketones reacts with this reaction. అర్థమైందా? Then now the one alkynes and two alkynes are separated by which of the following methods? One alkynes and two alkynes are separated by which of the following method? One is Tollens reagent. One alkynes and two alkynes are separated by A. Tollens reagent. B. Valence reagent. C. Grignard's reagent. Grignard's reagent. D. Ozone. అంటే ఓజోన్ అంటే ఓజోనాలిసిస్ రియాక్షన్.
All, sir.
One alkynes and two alkynes. One butane and two butane separated by which method? A is correct, B is correct, C is also correct. Acidic hydrogen is there in one alkyne, therefore it reacts with the Grignard's reagent. Two alkynes, no reaction. In ozonolysis also, double bond positions and even triple bond positions also identified by ozonolysis reaction because products are different. One butane on ozonolysis, propanonic acid, formic acid. But 2 butane on ozonolysis gives 2 moles acetic acid. Therefore, by using all these reagents, we can separate 1 butane and 2 butane. Okay, clear now? Like this question, they will ask in the entrance, sir. All these are previous entrance bits, sir. We arena questions and previous entrance bits. Like this question, they will ask in the entrance. Next one. In this aliphatic hydrocarbons, last one, comparative study between alkanes, alkenes, alkynes. Ane, ene, and ine. Alkane, alkene comparative study. First one, reagent here. Alkane. Next alkene. Next one alkane. Two alkynes. One alkene, two alkynes. Reagent is first one. bromine waters. Is it alkanes reacts with bromine water?
No, sir.
No. Test for unsaturation, sir. This one we are using for test for unsaturation. Alkenes unsaturation is there. One alkynes unsaturation is there. Two alkynes unsaturation. Bromine water has red color, sir. Alkenes and alkynes decolorize the bromine water. Okay, this one we are using for test for unsaturation. Next, second one. Cold alkaline KMnO4. Cold alkaline KMnO4 name anta?
Base reagent.
Bayer's reagent. What is the color? Pink color. Pink color. Perfect color. Is it alkane? This is also test for unsaturation. These two reagents we are using for test for unsaturation. Test for unsaturation. Is it alkanes reacts with Bayer's reagent? No. Alkenes, one alkyne, two alkynes. Unsaturation is there in all. Next one. Third one. Tollens reagent. Tollens reagent. Is it alkanes reacts with Tollens reagent? Ammonical silver nitrate. Yes or no? No. Alkenes, no. Only one alkyne, sir. Even two alkynes also not reacts with Tollens reagent. Fourth one. Fehling's reagent. Fehling's reagent. Same. One alkynes, no. Alkanes, no. Alkenes, no. One alkynes, yes. Two alkynes, no. Okay? Not reagent or in alkenes, no. Alkanes, no. Alkenes, no. One alkynes, yes. Two alkenes, no. Like this, weak not reagent. Sixth one. ఇవి reagent separations. Next one, bond length. How the bond length is present? Which one has more bond length? C single bond, next to C double bond, next to C triple bond. Single bond, double bond, triple bond. Next. Next one, bond energies. Bond energy is more for which one? Triple bond. Next to double bond. Next to single bond. Next bond angle 180 degrees. Triple bond. Double bond 120. Single bond 109 degrees. Next one, acidic nature. Same, triple bond, double bond, single. So this is about comparative study of alkanes. Aliphatic hydrocarbons completed. Aliphatic hydrocarbons are over. Aliphatic hydrocarbons over. ఇక్కడ మీకు పాలిమరేషన్ రియాక్షన్స్ కొన్ని ఉన్నాయి. ఇది కంపారిటివ్ స్టడీ సార్. పాలిమరేషన్ అంటే మీకు ఆల్రెడీ ఆల్కడైన్స్ చెప్పారు కదా, సేమ్ లైక్ దట్ సమ్ పాలిమరేషన్ రియాక్షన్స్ ఆర్ దేర్. పాలిమరేషన్ రియాక్షన్స్ ఏంటి? ఎస్టలిన్ ఆన్ సైక్లిక్ పాలిమరేషన్ ఇస్ విచ్ వన్? Sir, acetylene on cyclic polymerization. 3 moles acetylene. Huh?
Cyclo.
Red hot copper tube.
Benzene.
Red hot copper tube. Use benzene, sir. Cyclic polymerization use benzene. Next. 4 moles acetylene use. Same red hot copper tube. What it comes? COT. COT. Cyclooctatetraene. Cyclooctatetraene. 3 moles propane use. Red hot copper tube. Nistolene. Symmetrical trimethyl. 135 trimethyl benzene is called nistolene. Nistolene. 2 moles acetylene plus ammonia.
Pyridine.
Ammonia. 4 carbons ఉన్నాయి. Pyrrole. Pyrrole. Same red hot copper to pyrrole. 2 moles acetylene plus HCl.
pyridine, sir.
In this case, we are getting the pyridine. All these are cyclic polymerization reaction. 2 moles acetylene plus 2 moles acetylene plus H2S.
Hydroxy.
Redox property. So these are the polymerization reactions of alkanes. Polymerization reactions of alkanes. This is about the polymerization reactions of alkanes. Alkanes polymerization reactions are over. The next one. This is about alkanes chemical aliphatic hydrocarbons are over. Next, alicyclic hydrocarbons. Alicyclic hydrocarbons and what are the alicyclic hydrocarbons?
Cyclopropane.
Alicyclic. Alicyclic hydrocarbons. HC. In cycloalkanes. In our syllabus, cycloalkanes are there. Cycloalkanes. Sir, I will give some compound. General formulas of this compound, try and know. First one, cycloalkanes. Second one, cycloalkenes. Next one, cycloalkynes. Cycloalkanes. Fourth one. Cycloalkenes are monocyclic olefins are same. Cycloalkenes are monocyclic olefins. Monocyclic acetylines, both are same. Monocyclic aldehydes. Monocyclic ketones. Monocyclic ketones. Sixth one, monocyclic acids. Monocyclic acids. Monocyclic monoacids అన్నమాట ఇవన్నీ కూడా monoacids, monoaldehydes, monoketones. Monocyclic alcohols. Monocyclic alcohols, aldehydes, ketones. Monocyclic ethers. Monocyclic ethers. Monoethers అంటే one oxygen. Monocyclic primary amines. Try చేయండి సార్ 2 minutes. 2 minutes break తీసుకొని try చేయండి. I will continue the class. Up to 7 organic. 8 for 2 minutes.
క్లాసులు చెప్తారు ఏం మాట్లాడతారు మారుతుంది స్కిన్ పైకి వెళ్ళాడి రాత్రినట్టుంది అయిపోయింది అయిపోయింది క్లాస్ అయిపోయింది ఇదిగో కట్ చేసేది చెప్పేది లాస్ట్లో ఏమన్నా ఆలోచన ఇచ్చాడు నువ్వు ఈటే టింగర్ మొకందానా ఇంకో మళ్ళీ మరి ఇది కట్ అయింది